exposure, the roll control of the launcher will be tuned in order to make sure that Webb is always oriented only one face to the sun. And in addition, to avoid any hotspot, the launcher will create some oscillating movements, like a barbecue mode, to avoid any overheating. And after Webb separation, there will be a specific end-of-life maneuver to be applied on the upper stage in order to put it on a liberation orbit around the sun in order to avoid collision in the long term.
Thank you very much indeed, Daniel. So we'll hopefully see the upper stage rocking in space. Not quite all the way around like the familiar barbecue, but a slightly different movement. Listen, gentlemen, thank you very much indeed for being with us today. I know that you're busy. You've got jobs to do inside the fishbowl, so I'm going to send you right back there now, and very best wishes for the launch. Thank you.
Thank you.
Our telescope has a long journey ahead of it. It's got to travel 1 million miles to its destination in space, its working zone, where it's going to start telling us all about our universe. It's already started that journey because it's traveled to the launch pad from Los Angeles. After final tests were concluded in Los Angeles, Webb was packed into a special container and transported along the LA 405 freeway, which had to be closed because it's so big. It traveled on a special ship. A lot of spacecraft will come to the
Hello, hello. Welcome to the live stream for the James Webb Space Telescope with Astra. I'm just testing this out for the first bit here, so we'll see how successful it ends up being. I am definitely not familiar with a lot of the live streaming stuff yet, but let's try it out and see how it works. So yeah, basically we're going to go through and talk about what is special about the James Webb Space Telescope and also the vehicle which it's launching on. We're just going to follow the NASA live stream for this broadcast. And you can also go check out their stream. There's a lot of interesting information that they share about the telescope on their stream as well. But yeah, this is definitely probably the most important launch, I would say, of this year. The telescope that's going up is one that's been in development for definitely 20 years, but it was even in the drawing board and in the engineering phase for much longer than that. So it definitely has a lot of people on edge to make sure that this launch will be successful. Yeah. As we go, I think it would be nice if people want to ask questions in the stream as well. They can definitely do that, and I can answer some of them, hopefully. Yeah. So yeah, we'll be switching back and forth between myself and also the NASA broadcast over the course of the stream. So the planned launch time for the vehicle is going to be at 1:20 European Standard Time. So that's going to be in just over 15 minutes. I think, oh yeah, T-minus 17 is what's on the clock right now. So if all goes well, we should see the vehicle going up then. Just to give you a little bit of context, the Space Telescope is going to be going up on an Ariane 5 launch vehicle. So that is a European built vehicle by Arianespace, which is a conglomeration between the French company Safran and Airbus, and it's basically their flagship launch vehicle. it also, where the James Webb Space Telescope is going is a special place. The telescope is going to a place where it doesn't want to have very much interaction from the sun. Obviously, if the sun is in the picture, you can't take a good picture of space. You need to be very, very dark and cold. So the James Webb Space Telescope is going into a special location called the L2 Lagrange Point. And so what this means is it's going to go about a million kilometers away from the Earth, and it's going to be in a gravitational place where where basically it can sit in one spot, and it's going to be permanently in Earth's shadow. So that'll keep the telescope relatively cold and will minimize the effect that the sun will have on the telescope. But getting there is a bit difficult, so you need a really big launch vehicle that can push it all the way to that faraway spot. And there are only a couple of vehicles in the world that can do that, and the best one for the job in this case is the Ariane 5. But yeah, let's switch back to the NASA audio, and then we can continue from there.
Dr. Z, thank you very, very much for joining us. And I want to wish you and all the teams, everybody, the very best for today's launch. Thank you.
Go Webb.
So, yes, indeed, go Webb. So we are now 14 minutes and 30 seconds to launch. We're getting really close now. Everything's going well. All systems are green for launch. And I'm going to hand you over now to NASA's Rob Navius in the skybox alongside the European Space Agency's Luce Fabregat, who are going to take on the commentary from here on in. Over to you guys. Rob.
Well, thank you, Katie. Merry Christmas to our worldwide audience from our broadcast booth high atop the Jupiter Control Center here in Kourou. Joining me today for this historic launch, my colleague Luce Fabregat, the head of infrastructure and value chain for the European Space Agency. Luce, good morning.
Good morning,
great to be
Rob.
with you. Great to be with you today.
Very pleased to be here with you and all of you watching us for this very special event.
Well, at this hour, countdown clocks are ticking backward. We are at T-minus 13 minutes, 32 seconds and counting. Out on the launch pad, everything is in great shape. Don't let those clouds fool you. We are go for launch. The latest weather briefing just completed indicated that all weather parameters are green. We have a green board here in the control center, and everything has gone extremely smoothly in the countdown. About 9 minutes ago, a major milestone passed as the James Webb Space Telescope began the process and completed the process of receiving commands to transition from external power to internal battery power following the latest in the series of those weather briefings. Webb will remain on internal battery power until its singular solar array unfurls about 30 minutes after launch. Earlier, telescope controllers reported good environmental readings from sensors inside the fairing encapsulating the telescope atop the upper stage of the Ariane 5 rocket. And Luce, as we enter the most critical phase of the countdown, can you outline some of the upcoming critical activities as we head into the phase called synchronized sequence?
Yes, Rob. We are now reaching the end of this 11-hour sequence that we call the chronology, and that started yesterday evening. All systems here have been prepared for the final launch operations. And at the time being, it's rather quiet now inside the launch table and also inside the launcher. We were told a few minutes ago by the launch control center here that the launcher fluids and electric systems are ready for the final automated sequence. They are on hold now, waiting for the last weather report at minus 10 minutes. After this weather report, 3 minutes later, we will have the beginning of this famous synchronized sequence when all systems will be made ready for the liftoff. This sequence will first be run by the ground calculator, and then the onboard computer will take the lead step by step, and the launch vehicle will be made autonomous from the ground system. You know that we have 2 tanks in each cryogenic stage, upper stage and main stage. All 4 tanks are, of course, thermally insulated from the hot environment we have here in French Guiana. However, these liquid propellants are at very low temperature, and because of that, slightly evaporate. And to ensure they are perfectly loaded at liftoff, their final loading and topping up will last up to 4 minutes before the launch. So that will be the beginning of the synchronized sequence run by the ground calculators. Then we will have on the fleet side the end of the topping up, the final loading and the topping up of the different tanks. And on the electrical side, we will have the onboard computer getting prepared for the launch also, and it will be uploaded with the H0, with the H0 time, the time for the liftoff, which is today at the beginning of the window, 9:20 local time, 7:20 Eastern time.
One of the things that makes the James Webb Space Telescope special in terms of its ability to take the James Webb Space Telescope to orbit, the Ariane 5, sorry, is that it has a very large payload fairing. So the James Webb Space Telescope is a really big telescope, and it takes up a lot of space. And so many of the payload fairings on a lot of the launch vehicles, like the Falcon 9 or the Proton launch vehicle, they're just not big enough to accommodate the size of the James Webb Space Telescope. So this is one reason why the Ariane 5 is the best vehicle for the job. But also, the Ariane 5 has a unique characteristic where it's able to get relatively large masses onto orbits that are going pretty far away from the Earth. So this is because it uses hydrogen and oxygen as a fuel for its primary stage and also for its second stage. Usually launch vehicles like this have multiple stages, and this is what allows them to be more efficient and get enough mass into orbit. Anyways, the main point here though is that because it uses hydrogen and oxygen as its propellants, it's getting a lot of specific impulse, which is basically what is the efficiency of the rocket. If we were using, like for instance, a Falcon 9, the Falcon 9 uses liquid oxygen and RP1, which is basically kerosene, and that's not quite as efficient. So just in terms of the vehicle's ability to efficiently get the payload into the orbit that is required, a Falcon 9 wouldn't be able to do the job. So this is why Ariane 5 is uniquely the vehicle for the job. And they were just talking about how they have special propellant loading procedures because of this. So basically, the hydrogen and the oxygen are stored at a really, really cold temperature. They need to go down to, for oxygen, it's below, I think it's minus 180 degrees Celsius in order for it to become a liquid. And hydrogen needs to go down to minus 250 degrees Celsius in order for it to be a liquid. And keeping those things cold is really, really a challenge. So what they will do is they will basically keep loading this cryogenic propellant into the vehicle until just a couple minutes before they launch, and then they'll take the tube away and basically launch it in that configuration. But yeah, you have to, the whole process to prepare the vehicle for that is definitely an involved one, and you have to make sure that that all things are going smoothly throughout the entire process, and that's what they're doing right now, essentially.
The topping off of the main stage tanks. The first or core stage was loaded earlier this morning with 175 tons of propellant, 150 tons of liquid oxygen, and 25 tons of liquid hydrogen. The upper stage loaded with 15 tons of propellant. That will be the workhorse for a 16-minute burn to lift James Webb to its final orbit. At separation, some 27 minutes and 7 seconds after launch, James Webb will be at an altitude of about 864 statute miles. To put that into perspective, some 520 miles higher than the Hubble Space Telescope and more than 600 miles higher than the International Space Station. Webb at that point will be traveling about 21,000 miles an hour as it heads out to a highly elliptical halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
In a little more than 1 minute from now, we will see the 4 tanks pressurized at their flight level for the last tests before the ignition of the Vulcan engine. And in parallel, the electric system are also set in flight configuration, the onboard computer, the electrical power. As for the telescope,
Here's another interesting. This is actually a really good picture of the engine there. That's the Vulcan engine, and it's a really big one. They just have one for the primary stage, which is, I would say, a bit unique for launch vehicles today, because usually they're using many engines on the primary stage, but the Ariane 5 just uses one. Instead, it uses the side boosters. You see them when they zoom back out the whole vehicle. You'll see 2 side boosters, and those are powered by solid propellant. And the main stage is powered by liquid, which is the oxygen and the hydrogen. The reason for that is that the hydrogen-oxygen combination is not a very powerful one. So all by itself, the vehicle actually wouldn't be able to lift its own weight. So it needs those 2 solid boosters in order to give it enough power so that it can get off the ground. So yeah, the hydrogen-oxygen combination is certainly a very efficient one, and is really good for getting you up to a really high speed efficiently, but it's not powerful enough usually to take off from the ground. This is a little bit like the space shuttle. It had the same problem because it was also using a hydrogen-oxygen combination for its engines, and it also needed those 2 side boosters in order to lift the vehicle into an orbit. And they're just saying here on the webcast that the solid boosters provide 90% of the thrust on takeoff. So really, that main engine there, although it looks really big, it's actually not providing a lot of the thrust at the start. It's mostly those side boosters.
Seven-second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes, 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2-minute, 50-second mark into the flight. Again, you're going to be hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer.
And we're getting close here. It looks like we're a go on weather, so this is good. Weather is often a phenomenon that will potentially delay a launch because higher altitude winds can sometimes affect the ability of the vehicle to compensate. But it looks like we're all good here.
Manager Jean-Luc Voyer, as we have hit the 2-minute mark in the countdown.
The flight will be in 2 phases. You will see the first part of the flight, during the solid rocket boosters phase. That will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by to reduce the aerodynamic loads.
I think it's looking good. We're at just a minute left here. I would say that we're at a high likelihood of getting to see this thing take off. Yeah, so we're within 1 minute now. So we just got the...
As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7 seconds, and the command will be issued to ignite the solid rocket boosters. The James Webb Space Telescope will be on its way.
So we just got the all clear for the vehicle. It's ready to go.
T-minus 30 seconds and counting.
I don't think there's going to be a hold now unless there's some sort of engine problem. Once they light those solid boosters, there's basically no going back. You can't stop a solid booster once they get started.
Six, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff.
And there it goes.
Decollage.
Here we go.
Liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire est nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion.
It's really too bad we have the clouds.
The rumble
can't really
of the
see it
powerful Ariane 5
from the ground station.
Here in the control center. 3D animation.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
13 kilometers in altitude, 7 kilometers downrange, traveling about 0.6 kilometers per second.
Tous les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the range operations manager. You can see at the bottom of your screen, the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute, 41 seconds into the flight, about 40 seconds away from shutdown of the solid rocket boosters. Coming up on the 2-minute mark into the flight.
So they're about to shut down the solid motors, and then they're basically going to separate. They're going to come off to the side. So this is also a critical point in the rocket phase here. And here they go. That's the booster separation. So now it's just the main engine that's powering the vehicle. It's far enough out of the atmosphere now that it doesn't need to have those that big force from the solid rocket boosters anymore. So it's now basically, for all intents and purposes, flying in space.
Milestone.
The fairing is there to avoid the satellite being exposed to high temperatures.
So the main booster on the Ariane 5 then burns for another couple more minutes, and then it's also going to separate, and then you're going to see the second stage ignite. We need to have multiple stages in order to get payloads into orbit usually, because one stage doesn't have enough delta velocity in order to get into Earth orbit. So this is why we basically will do a staging, which is ultimately putting a little tiny mini rocket on top of the big rocket. And here we just had the payload fairing separation. That's the pieces that were protecting the telescope from the air as it was ascending. But now, since it is already 136 kilometers above the Earth, there's not much air left, so we can get rid of that mass so that the vehicle can go a little bit faster.
So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is on about a 20-second delay or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings basically and begin its journey to the Lagrange point, the L2 point, about 1 million miles away from Earth.
So in order to get to Earth orbit, you need about 7.8 kilometers per second of velocity, and so you can see the velocity in the bottom left-hand corner here of the screen. It's the vitesse, which is, I believe, velocity in French potentially. I'm not super familiar with French, but I think that's what it is. So once this velocity gets to around 7.8 kilometers per second, you'll know that it has officially gotten into orbit. And then it's going to have to go even faster, about nearly almost 11 kilometers per second, in order to get into the L2 Lagrange point that it wants to go to. But the second stage is going to be what takes it there.
Go in main stage or first stage performance. And again, you can see at the bottom of your screen the yellow plot line overlaid over the green line, meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5 rocket.
Paramètres à bord sont normaux.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are in.
Yeah, so far the telescope is right on trajectory. It's looking really good for what they're expecting. It would be very rare that a launch vehicle would fail at this point. So the scary part is over, I would say. So it definitely looking positive. In order to get into the orbit that Ariane 5 wants to go into, they are basically flying to the east. And the reason why they do this is because they want to take advantage of the rotation of the Earth to help them get a little extra velocity that pushes them onto the orbit. So basically at the Earth's equator, the velocity of the Earth is about 300 or 400 meters per second. So that's about 0.4 kilometers per second. And that gives you about 7 or 8% extra velocity towards your final target of getting to the 7.8 kilometers per second. So it's better to take advantage of that rotation. And that's the reason why the Ariane 5 launches from Kourou in French Guyana in the first place. It's because it's near the equator. If you were to launch a vehicle somewhere in the European region, you would have much less velocity that would be assisting you in order to fly towards the east. The other problem is that in order to launch a payload like this into the orbit they want to go into, they need to go into an equatorial orbit. So the orbit has to go around the center of the Earth. And if you're launching from a northern location, like from Germany or from France or from the UK, you can't really get into that type of an orbit because you are already you're not at the equator, and you have to go to the equator and then go into orbit. And making that orbit change is a very, very costly maneuver. So it's much better just to find a launch location that's closer to the equator in order to make it easier to get into these types of orbits. And that's why launch complexes try to usually be in the most southern part of the country that you can find. So like that's why they have the Kennedy Launch Space Center. That's why it's in Florida, is because that's the southernmost point of the United States.
La trajectoire est normale.
Nominal trajectory continues to be the watchword for the day from the Range Operations Manager, Jean-Luc Voyer, as we stand by for main engine shutdown and separation.
And there the first stage just separated, and now the second stage is taking over. And you can see we're almost in the orbit that we want to be in.
Yes, Rob, we have the confirmation of the separation of the main stage and the ignition of the upper stage. The trajectory is perfectly nominal. This is a very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal, as the DDO just said.
So as they were just mentioning, the second stage is going to burn for 16 minutes. So it's a lot less powerful than that first stage, which was able to get up to 7 kilometers per second in just under 10 minutes. This one is now going to stay on for like he said, 16 minutes, and that's going to take them all the way up to the velocity that they need in order to get the James Webb onto that orbit that's going to take it about a million and a half kilometers away from the Earth. And that's where the L2 Lagrange Point is, which is where the spacecraft will be living for the next, for basically the duration of its mission. And the reason why that's so important, that it goes to this L2 Lagrange Point, is because this is where the telescope can open and can start observing and have the least influence from the sun affecting it. One of the problems that they have is because they want to observe in the infrared spectrum, heat is the main issue for the sensors on the telescope, and so you have to keep those sensors really, really cold, like cryogenically cold, minus 250 degrees Celsius cold. And of course, if the sun is there always shining on the spacecraft, that creates interference with that with your measurements, and so you want to have special techniques to keep the spacecraft cold. And one of those is to put it into the L2 Lagrange point. There's also a special sun shield that the spacecraft has, because there'll still be some sunlight coming through in that location. And this shield is designed to stop the heat from the sun from getting to the sensors of the spacecraft. And of course, you can see here the telescope is all kind of crumpled up in its configuration aboard the second stage of the spacecraft. Of course, it had to be like that in order for it to fit inside of the payload fairings of the spacecraft, basically of the Ariane 5. But what it's going to do is it's going to unfurl. So first the sun shield and the solar panels are going to unfurl for the spacecraft, and that's going to protect the spacecraft from the sun. And then finally the actual dish of the telescope, which you can kind of see, it's the gold hexagons. That's where basically the lens, not the lens. It's a mirror. It's going to be the primary mirror that's going to be focusing the light that's going to go into the sensors of the spacecraft. And yeah, with this configuration and with the size the telescope is, it's the biggest space telescope ever launched. And with this telescope, they're going to be able to investigate. They're going to be able to look further into the universe than they ever could before, and they're also going to be able to see things that they weren't able to see before. And one interesting aspect that the telescope has is that it's going to potentially be able to see exoplanets. we've been looking for exoplanets for the past 20 years or so, using techniques where we're looking at the star. So we look at the brightness of the star, and we can sometimes see brightness dips when planets cross between the sun, between us and their star. We also use techniques where we look at how stars move, because of course if there's a gravity of a planet pulling on the star will move back and forth. But one thing we haven't been able to do yet is actually just take a picture of the planet itself, the exoplanet all by itself. And that's one thing that potentially James Webb Space Telescope might be able to do, because it's looking at the infrared part of the spectrum, and everything gives off infrared light. It's just basically heat. And it has a sensitivity where it could potentially be able to observe an exoplanet.
And again, Luce Fabregat from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot, the altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of its altitude, slight decrease of its altitude, will allow the launcher to benefit and the upper stage to benefit of the gravity effect, and to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now.
So what they're talking about right now is actually an interesting orbital effect called the Oberth effect. So in order to most efficiently raise the orbit of a vehicle, right now, when the second stage turned on, the spacecraft was almost in a circular orbit around the Earth. And what we need to do is we need to put the spacecraft onto an elliptical orbit that goes all the way up to the L2 Lagrange point. And so what you need to do is you need to burn your engine when you're closest to the Earth, and that's when you get the most effect out of your orbit change. And well, because we have such a long burning motor, which is the second stage of the Ariane 5, is this motor that burns for 16. The engine burns for 16 minutes, which is a really long period in the path of an orbit. An orbit around the Earth takes about 92 minutes when you're in low Earth orbit. So that's going a significant percentage of the way around, which means that you're not always going to be in that place where you're closest to the Earth. So what they've done here is they've arranged the orbit such that basically they will be closest to the Earth right around the middle of the burn of the second stage motor. So that was kind of the parameter that they're trying to optimize here. And that, again, that's called the Oberth effect, where you're trying to get the most out of your velocity when you're close to the Earth.
We're about 8 minutes away from upper stage shutdown. The stage has performed as planned. No issues reported. The launch occurring at 12:20 Greenwich Mean Time, 9:20 Kourou time, 7:20 a.m. Eastern Time on this Christmas Day.
Very smooth. The velocity you just mentioned is very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in kilometers per second, but it will be slightly below 10 kilometers per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layout, for the early.
So this is actually another interesting part about this orbit that they're trying to get into, which is that it's very close to the escape velocity of the Earth itself. So you have to be very precise about when you turn off the engine for the second stage. If they push it too far, then you could end up on an orbit where the Space Telescope will actually escape Earth's gravity and not get to this L2 Lagrange point. So they have to be very careful that they turn off the motor, the engine, right before they get to their critical velocity, which I think is going to be about 10 kilometers per second, which is what they said. So yeah, we hope that goes well. I'm sure there won't be a problem though.
So the flight. It's very quiet now here in the control center here in Kourou. NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully. And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute, 51-second mark into the flight, about 5.5 minutes from now.
Yeah, so we're nearing now the end of the burn. We only have about 5 minutes left, and then it should be at the 10 kilometers a second roughly that they need in order to push the spacecraft to the L2 Lagrange point. And yeah, it takes actually a really long time for the vehicle to get to this point. So because it's on this elliptical orbit, the vehicle will get, or the space telescope, it's going to separate from the second stage. But to go on an orbit that is this long is going to take it some many days to get all the way out to the L2 Lagrange point, and then it's going to have its own onboard thrusters that are going to change its orbit at the apogee of this orbit, and then it will be putting itself into this L2 Lagrange point orbit that it needs. But that'll happen many days from now. That's not going to happen today.
Trajectoire normale, tous les paramètres à bord sont normaux.
All parameters nominal as reported by Jean-Luc Voyer, the range operations manager. 4 minutes of powered flight remaining.
You can see here on the ground track that the spacecraft is now passing over Africa. So you can just think about how fast it got all the way to Africa. It's only been about 20 minutes and it's already traveled across the entire Atlantic Ocean. So that gives you a little bit of perspective about just how fast this 9 kilometers a second that the vehicle is going really is. Yeah, it's definitely a lot faster than you might imagine. And certainly faster than anything that you've ever seen in your life, probably.
"22 minutes into the flight. Less than 3 minutes of powered flight remaining.
Pilotage est calme.
Smooth flight control.
And again, as we've mentioned
Les
before,
paramètres à bord sont normaux.
everything nominal reported by the range operations manager. As we've mentioned before,
Acquisition de la
this is a
télévision par la
long
station de
ride
Malindi
uphill
au Kenya.
for the James Webb Space Telescope to put it at the proper position in the sky so that it can escape from the Earth, basically head beyond the moon towards its final orbit for its commissioning activities that will be the dominant feature of all of the operations from the Space Telescope Science Institute over the course of the next several weeks.
And the launch operations manager announced the acquisition by Malindi, by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight. and the separation of the telescope.
James Webb is about 4 minutes away from separating from the upper stage. And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore. 1 minute of powered flight remaining. The upper stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
Trajectoire est nominale.
So we're in the last minute here. Everything has gone nominal up to this point. There's going to be a 2 minutes. There's going to be a 2 minute hold, or not a hold, but a 2 minute period between when the engine turns off and when the telescope will separate. And this is just to damp out the oscillations that could be in the vehicle because the engine was suddenly turned off. They want to be very cautious about making sure that nothing will interfere with itself as the telescope separates. And there you go, we just had the upper stage engine cut off. So now we're going to have a coast for two minutes, and then they're going to separate the James Webb Space Telescope from the second stage.
The extinction of the shut-off of the cut-off of the engine was confirmed exactly as expected, with the exactly expected altitude and speed and velocity. So now we have entered the coasting phase, the ballistic phase, that will last for a little more than 2 minutes.
You'll notice that the velocity is now decreasing, and that's nothing to worry about. The reason why that's happening is because now the vehicle is on an elliptical orbit, and so basically as it goes all the way up to apogee, it's going to slow down, slow down, slow down, and slow down. So this isn't a problem or anything.
A flight. Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5. As it moves further and further away from the upper stage, there'll be what we refer to as a collision avoidance maneuver.
Yes, Rob, exactly. The springs already will give some distancing, of course, between the two objects, between the telescope and the upper stage. And then the upper stage will leave the trajectory of the telescope and makes a special maneuver to pass the telescope and heads towards a liberation orbit and leaves the telescope on its orbit without any risk of collision and without any risk of pollution towards the telescope.
So once the telescope leaves the second stage of the spacecraft, they're very concerned that the spacecraft could potentially bump into the telescope. So they have a whole plan to basically have this telescope power itself away. Oh, here we go. That's the separation. And then, the telescope will then use its thrusters to further distance itself from the space telescope in order to prevent any potential collisions.
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery.
So there you have it. The James Webb Space Telescope successfully delivered into orbit going towards the L2 Lagrange Point. This is definitely a successful launch with a successful result. And there you go. You see the live broadcast of the telescope separating. Yeah, definitely really a big accomplishment for all the people that were involved. And I'm sure there are many scientists all around the world that are super excited to potentially have this spacecraft operating and working and sending back some data and some pictures that go back all the way into the early universe. I'm definitely excited to see the research that comes out of the Space Telescope, because there's definitely going to be a lot that we're going to learn. And one thing I'm definitely looking out for is the potential new information that we're going to have with respect to exoplanet research. But yeah, we wish the James Webb Space Telescope healthy travels all the way into the L2 Lagrange Point. And yeah, keep up with the Astra channel. We'll be definitely giving some updates on this and other types of missions like this. Thank you for watching the webcast, and we look forward to seeing you in the future.